Hello everyone, welcome to our channel. In this video we are going to solve a problem on physics portion. This problem came in the year 2017 in JAM Biotechnology paper. Here the question is, an X-ray tube operates at 30 kilovolt. If one electron converts 10% of its energy into a photon at first collision, then the wavelength of the photon correct up to 2 decimal places is how much angstrom. Okay, and given is H equal 4.14 times 10 to the power minus 15 electron volt per second, C equal 3 into 10 to the power 3 meter per second, and E equal 1.6 into 10 to the power minus 19 coulomb. Okay. Now first of all, I should say that here the unit of H, that is Planck's constant. We know that H is Planck's constant. So in the unit of H, this second inverse is wrongly stated. Okay, because we know that the unit of H is joule second or electron volt second. It can be electron volt second but not per second. That is, electron volt second inverse is wrongly mentioned here. Okay, it is wrong here. So it should be electron volt second. Okay, and in the value of C here, it is given that it is 3 into 10 to the power 3 meter per second, but we know that the value of C, that is the velocity of light in vacuum, is equal 3 into 10 to the power 8 meter per second. It is not 3 into 10 to the power 3 meter per second. Okay, that is velocity of light in vacuum, that is C equal 3 into 10 to the power 8 meter per second. Okay, so now let's solve this problem. So if this type of wrong things are given in your question, your answer using these values would be counted. Okay, so let's solve this question now with correct values. Okay, so here first of all we need to find what we need to find. We need to find the wavelength of photon. Okay, the wavelength of photon, and given is that the energy of photon is 10% of energy of one electron. Okay, so what is the energy of photon, or how can we calculate, or what formula should we use to calculate the energy of photon? We all know, I hope you all know, that E equal h nu, right? Quantization of energy, I hope you all know, E equal h nu. So if we write it in terms of wavelength, we get equal hc by lambda, right? Equal hc by lambda, where h is Planck's constant, nu is frequency of light, h is again Planck's constant, c is velocity of light in vacuum, and lambda is wavelength of light or photon. Okay, and E is the energy of photon. Okay, so if you ask me that how I get this nu equals c by lambda, I should mention that c equal, we know c or velocity is equal nu lambda, that is frequency times wavelength. From here we get nu equal c by lambda. Okay, now if we put the values of E, H, C, we can calculate this lambda, right? So what is the value of E? What is the energy of photon? See, here it is said that energy of photon is 10% of the energy of electron, right? So 10% of this 30 kV, here it is not 30 kV actually. In terms of energy, it is 30 kilo electron volt. If you use here kV and here only here electron volt second and here only kV, then your answer would be wrong. Okay, so it is 10% of 30 kilo electron volt equal hc by lambda. Let us put the value of h. We have put value of E, so that is equal the value of h, that is 4.14 times 10 to the power minus 15. So let us first remove it from here. Okay, so minus 15 times EV S, right, electron volt second, multiplied by the value of C, right? If we put the correct value of C, that is 3 times 10 to the power 8 meter per second, or meter, I should write it here like this, that is second inverse. Okay, divided by lambda, right? So how much is 10% of 30 kilo electron volt? 10% of 30, right? That means 10 by 100 times 30 kilo, that means 10 to the power 3 EV, right? Now this is equal this thing. Okay, so now if we calculate lambda, it is equal 4.14 times 10 to the power minus 15. See here, electron volt cancels out, second inverse cancels out, and we get 4.14 times 10 to the power minus 15 times 3 times 10 to the power 8 meter divided by 10 by 100 into 30 into 10 cube. Okay, so here we get it as 4.14 into 10 to the power minus 10 meter. Okay, and we need to calculate it in Armstrong. So what is Armstrong? Armstrong is 10 to the power minus 10 meter, right? So 4.14 Armstrong. So our answer is 4.14. Okay, so our answer is 4.14. This is our correct answer. So if you have any doubt regarding this solution, you can tell me in the comment section. If you like this solution, please click on the like button, share this video with your friends, and don't forget to subscribe our channel. Ta-da!